May 1st, 1851. The Crystal Palace, Hyde Park, London. Among the 100,000 visitors crowding the glass and iron exhibition hall, Joseph Whitworth moved methodically through the American section, a leather case of measuring instruments under his arm. The great exhibition showcased 13,000 exhibits from around the world, but Whitworth had come specifically to examine the American firearms that had won shooting competitions and captured international attention. Samuel Colt's revolvers gleamed in their display cases. Springfield Armory muskets stood in proud rows. American manufacturers proclaimed their achievement of the holy grail of production, interchangeable parts, the system that would revolutionize manufacturing and make America the workshop of the world. Before we continue with the video, if you're listening right now, help me prove something wrong. My wife said I wouldn't even reach 1,000 subscribers, but I believe stories about old machines like this deserve to be heard. Help me. Show her that these videos matter. Please subscribe to our channel and let's keep these old machines' legacies alive. Whitworth removed a precision micrometer from his case, an instrument he'd spent years perfecting in his Manchester workshop. The American exhibitors watched curiously as this British engineer, already famous in Europe for obsessive precision, began measuring their showcase products. A Colt revolver cylinder, supposedly identical to dozens of others, registered .374 inches diameter. Whitworth measured another supposedly identical cylinder from the same batch, .376 inches. A third, .372 inches. The variation was only 0.004 of an inch, invisible to the human eye, acceptable by every standard of 1851 manufacturing. But Whitworth's instruments could measure to 0.010 of an inch, and what they revealed disturbed him profoundly. No two parts matched. He moved to the Springfield musket barrels. The bore diameter, critical for accuracy and safety, should have been uniform across all rifles marked as .69 caliber. The first barrel measured .688 inches, the second .692 inches, the third .686 inches. Variation of 0.006 of an inch in what Americans celebrated as precision manufacturing. Whitworth made careful notes in his leather journal, his handwriting precise as his measurements. The American exhibitors smiled and accepted congratulations from visitors. Their medals from the exhibition would be shipped back to Springfield and Hartford, proof of American manufacturing superiority. But standing in that glass palace, measuring the gap between American claims and American reality, Whitworth understood something the celebrating manufacturers did not. Their parts weren't interchangeable. They were hand-fitted, filed, adjusted by skilled craftsmen until they worked together. Strip down any American rifle, mix the parts with pieces from another supposedly identical rifle, and nothing would fit. The emperor of American manufacturing had no clothes, but only Whitworth's instruments were precise enough to reveal the truth. Back in the United States, Springfield Armory was producing 10,000 muskets per year. Colt's Hartford factory employed 1,400 workers making revolvers. Clockmakers in Connecticut, textile machinery builders in Massachusetts, locomotive manufacturers in Philadelphia all proclaimed they had mastered uniform production. The American system of manufacturing was celebrated in newspapers and technical journals as the future of industrial production, the democratic alternative to European craft tradition where every product was unique. The reality was chaos hidden behind marketing. When a rifle broke in the field, soldiers couldn't simply replace the damaged part. They needed a skilled armorer to file and fit a replacement. Clock factories couldn't repair their own products without master craftsmen. Textile mills kept armies of mechanics employed doing nothing but adjusting and modifying machinery that should have been identical. But in 1851, American manufacturers were too busy celebrating their Crystal Palace medals to acknowledge the problem. And they certainly weren't listening to a British engineer who insisted their triumph was built on measurement too crude to reveal their failure. This is the story of how one man's obsession with precision to the 10,000th of an inch created the foundation that made American mass production actually possible. Joseph Whitworth was born December 21, 1803 in Stockport, England, son of a schoolmaster, who emphasized mathematics and precise thinking. At 14, he went to work in his uncle's cotton spinning mill in Derbyshire, his first exposure to the chaos of early industrial machinery. Mills shook themselves apart. Shafts wore through bearings in weeks, parts broke constantly, and replacements never quite fit. By 19, Whitworth had moved to Manchester, the beating heart of Britain's Industrial Revolution, and apprenticed himself to Henry Maudslay, the man who would change his life. Maudslay was already famous for building the first truly precise metalworking lathes. His workshop philosophy was simple and absolute. First, get a true plane, and all else follows. A perfectly flat reference surface was the foundation of all precision. Maudslay had young Whitworth scraping metal surfaces by hand, checking flatness by coating one surface with red lead and rubbing it against another. High spots showed up bright red. Scrape them down. Check again. Repeat for hours, days, weeks, until the red lead spread uniformly across the entire surface. Only then was a surface true. This obsessive attention to accuracy struck Whitworth as revelatory. The 1820s and 1830s saw Britain's industrial output exploding, but beneath the triumph lay profound disorganization. Every factory used different measurements. Every craftsman worked to different tolerances. The chaos was worst with screw threads. A bolt made in Birmingham wouldn't fit. A nut made in Manchester. A machine assembled in Liverpool couldn't be repaired with parts from London. Even within single factories, bolts and nuts were hand-matched, filed until they fit together, then marked so no one would mix them up. It was craft tradition pretending to be industrial production. In 1829, Whitworth opened his own workshop in Manchester. Through the 1830s, he perfected Maudslay's true plane technique, using 3 surfaces scraped against each other until all 3 became perfectly flat. The method was ingenious. 2 surfaces can be made to match each other, but might both be curved. Only when 3 surfaces all fit perfectly against each other can all 3 be proven truly flat. From these reference surfaces, Whitworth built his measuring machine in 1841. It used mechanical advantage to amplify tiny variations, making differences of 1/10,000th of an inch visible to the human eye. When competitors worked to tolerances of 1/100th of an inch, Whitworth insisted on precision 100 times finer. That same year, Whitworth proposed his standard screw thread system to the Institution of Civil Engineers. British industry was using 47 different thread profiles. Whitworth's system specified everything: a 55-degree angle between thread faces, specific pitch for each diameter, rounded roots and crests to prevent stress concentration. Adoption was slow. Manufacturers resisted changing their practices. But through the 1840s, British factories gradually accepted that standardization and precision offered advantages over craft tradition and hand-fitting. Then came 1851 and the Crystal Palace Exhibition, where Whitworth encountered American manufacturers proclaiming they had achieved what he knew they hadn't. Their confidence intrigued him. Their measurements appalled him. When the British government commissioned him in 1853 to investigate American manufacturing methods, Whitworth accepted immediately. What he would discover in American armories would expose the greatest manufacturing myth of the 19th century. Whitworth arrived in America in 1853 with his leather case of measuring tools and a commission from the British government to study American manufacturing. He toured Springfield Armory in Massachusetts, Harper's Ferry in Virginia, Samuel Colt's factory in Hartford, clockmakers in Connecticut, and textile mills throughout New England. His initial impressions were positive. American factories were ambitious, operating on scales that impressed even a British engineer. Labor-saving machinery was everywhere, compensating for America's shortage of skilled craftsmen. But when Whitworth began actually measuring the products these factories celebrated as uniform and interchangeable, the illusion collapsed. At Springfield Armory, workers showed him musket barrels they claimed were identical, ready to be installed in any rifle without adjustment. Whitworth measured the first barrel bore at .688 inches, the second at .694 inches, the third at .686 inches, 0.008 of an inch variation in parts supposedly interchangeable. He measured lock mechanisms, trigger assemblies, barrel bands. Nothing matched, every part varied. American manufacturers had built an elaborate mythology around Eli Whitney's 1798 promise to the War Department 10,000 muskets with interchangeable parts that would revolutionize military logistics. But Whitney had never delivered. His muskets required hand-fitting. Every part was filed and adjusted by skilled workers until it functioned. The myth persisted anyway, amplified by American nationalism after the War of 1812, by marketing from ambitious manufacturers, by pride in democratic production methods that didn't depend on European craft guilds. Simeon North received contracts in 1813 and 1816 to produce pistols with truly interchangeable parts. After years of effort, he achieved partial success, but still required selective assembly, choosing parts that happened to fit together well. John Hall at Harper's Ferry came closest in the 1820s with his breech-loading rifle. Hall's parts were more uniform than anyone else's, but still needed skilled fitters to make rifles function properly. The fundamental problem was measurement. American factories had no precision measuring instruments. They used go-no-go gauges, simple metal templates that answered only yes or no questions. Does this part fit through the hole? Yes or no. But go-no-go gauges couldn't detect variation within acceptable ranges. A barrel might be .688 inches one day, .694 another, and both would pass through the same gauge. Workers relied on feel and experience, filing parts until they seemed right. Metal expanded and contracted with temperature changes, but no one measured or compensated for thermal variation. Steel quality varied between batches, even within single castings, causing unpredictable dimensional changes during heat treatment. These small variations compounded across multiple parts. A rifle used dozens of components, each part's variation multiplied with every other part's variation. Final assemblies never truly matched, even when individual pieces looked identical to the human eye. Whitworth documented everything in his report, published in 1854. He praised American ingenuity and labor-saving machinery, but buried in technical language was devastating criticism. American parts weren't interchangeable. American factories lacked measuring standards. American manufacturing was built on claims that Whitworth's instruments proved false. American manufacturers reacted defensively. They dismissed Whitworth as obsessed with unnecessary precision. Good enough was cheaper than perfect. American craftsman skill was superior to British machine consistency. The recommendations in Whitworth's report were largely ignored. But while American manufacturers celebrated their supposed superiority, a war was coming that would prove Whitworth devastatingly correct. April 12, 1861. Confederate artillery opened fire on Fort Sumter, and the Civil War began. President Lincoln called for 75,000 militia to suppress the rebellion. Both Union and Confederate governments needed weapons immediately, hundreds of thousands of rifles, millions of rounds of ammunition, artillery pieces, ammunition carriages, all the machinery of war. Springfield Armory ramped production from 800 rifles per month to a goal of 1,000 per day. Private contractors received massive orders, and almost immediately, the parts problem that Whitworth had documented 7 years earlier became a crisis. Battle-damaged rifles couldn't be repaired with supposedly interchangeable parts. A soldier whose rifle's lock mechanism broke couldn't simply install a replacement lock from another Springfield rifle. The parts didn't fit. Field repairs required skilled armorers who filed and adjusted replacement parts, the same hand-fitting process used in original manufacture. This wasn't an inconvenience, it was a tactical disaster. Broken rifles accumulated faster than armorers could repair them. Regiments went into battle under strength because weapons sat unusable waiting for craftsmen. After Gettysburg in July 1863, Union forces recovered 37,000 rifles from the battlefield. Only 12,000 were immediately serviceable. The rest required repair, and repair meant hand-fitting parts because interchangeable parts didn't actually interchange. Even ammunition caused problems. The Springfield rifle was supposedly standardized at .58 caliber, but actual bore diameters ranged from 576 thousandths of an inch to 582 thousandths. Ammunition that fit one rifle jammed in another. Artillery was worse. Cannon carriages from different contractors used different bolt threads, different axle diameters, different wheel hub dimensions. Replacement parts didn't fit. The Confederacy faced even greater desperation. Southern factories captured Union Springfield rifles and attempted to manufacture copies. But without precision measuring tools, Confederate copies varied even more than Union originals. Parts from captured Union rifles wouldn't fit Confederate manufactured copies even though both were supposedly the same design. Meanwhile, the Union was importing over 500,000 British Enfield rifles during the war. British manufacturers, using Whitworth's precision methods and measuring tools, produced rifles whose parts actually interchanged across different factories. Union quartermasters discovered that British Enfield parts fit better than American Springfield parts that came from the same armory. William Sellers, a Philadelphia engineer and manufacturer, studied the problem. He visited British factories and realized Whitworth had been correct. Precision measurement was essential for true interchangeability, but American pride demanded an American solution. In 1864, Sellers proposed the United States standard screw thread to the Franklin Institute. His system used a 60-degree angle instead of Whitworth's 55 degrees, with flat crests and roots instead of rounded. The differences were minor modifications of Whitworth's principle, but critically, the standard was American, not British. The War Department conducted investigations after the war. Congressional hearings examined armory manufacturing practices. Accountants estimated that lack of true interchangeability had wasted over $2 million, equivalent to $35 million in modern currency. Thousands of rifles discarded as unrepairable. Millions of parts manufactured that didn't fit. Soldiers killed because their weapons failed and couldn't be quickly fixed. The Civil War proved Whitworth right, but America's transformation required more than recognition. It required machines that could enforce precision. William Sellers presented his United States standard screw thread system to the Franklin Institute in 1864 while the Civil War still raged. His 60-degree thread angle differed from Whitworth's 55 degrees. His flat crests and roots replaced Whitworth's rounded profiles. The modifications were arguably better for mass production, easier to manufacture with simpler cutting tools. But the real reason for the differences was American pride. The nation that had dismissed Whitworth's precision as unnecessary British fussiness now needed exactly what he'd prescribed, but couldn't admit it by adopting his standard directly. The Franklin Institute officially recognized Sellers' system in 1868. Through the 1870s, American manufacturers gradually implemented it. Even Sellers acknowledged his system was built on Whitworth's fundamental principle: precision measurement enforces interchangeability. American factories began importing British measuring tools. Whitworth measuring machines capable of detecting variations to 1/10,000th of an inch, shipped across the Atlantic to workshops in New England and Pennsylvania. Francis Pratt and Amos Whitney, no relation to Eli, had established a precision tool company in Hartford in 1860. By 1864, Pratt & Whitney was manufacturing measuring instruments based on Whitworth's designs, bringing precision measurement within reach of American manufacturers. Brown and Sharp in Providence introduced a micrometer in 1867, again based on Whitworth's principles, selling for $6, equivalent to $120 today. The tools that American manufacturers had dismissed as unnecessarily precise in 1853 became essential equipment by 1870. Springfield Armory invested heavily in precision measuring equipment after the war. Workers were trained to use micrometers instead of relying on feel and experience. Master gauges were checked against reference standards based on Whitworth's true plane surfaces. By 1870, Springfield was finally producing rifles with truly interchangeable parts, 75 years after Eli Whitney's promise. The bicycle boom of the 1880s and 1890s spread precision manufacturing beyond armories. Bicycle factories demanded interchangeable parts so dealers could stock replacements. Sewing machine manufacturers like Singer and Wheeler and Wilson adopted precision methods so broken machines could be repaired anywhere. Agricultural machinery makers, McCormick and Deere, implemented interchangeability so farmers could fix equipment without waiting for factory craftsmen. The enforcement of precision required systematic changes. Master gauges in every factory checked regularly against standards. All production parts measured with micrometers, not just inspected visually. tolerances specified to 1/1000th of an inch instead of the previous 100th or larger. Temperature-controlled measuring rooms maintained at 68 degrees Fahrenheit to eliminate thermal expansion errors. Regular calibration of all measuring instruments. The initial investment was expensive, but reduced waste and enabled scaling production to volumes impossible with hand-fitting. Workers changed, too. The skilled fitter, who spent years learning to feel when parts matched properly, gave way to the machine operator who followed precise specifications. Training shifted from apprenticeship to technical instruction. Read the micrometer, compare to specification, accept parts within tolerance, reject parts outside tolerance. The human judgment that American manufacturers had celebrated as superior to British mechanical precision was systematically removed from production. Joseph Whitworth died January 22, 1887, age 83. The British government had knighted him in 1869, recognizing his contributions to engineering and manufacturing. By his death, American factories were using his methods even if they rarely mentioned his name. Whitworth standard threads dominated global manufacturing everywhere except America, but Whitworth's fundamental principle that precision measurement enables interchangeability dominated everywhere, including America. The irony would have amused him. Americans had spent decades insisting his obsessive precision was unnecessary, then built their industrial dominance entirely on that precision while crediting themselves for the innovation. Henry Ford introduced the Model T in 1908, and true interchangeability became absolutely essential. The assembly line required parts that fit together without adjustment, without filing, without craftsmen making individual judgments. Ford's factories measured everything with precision instruments descended directly from Whitworth's designs. Tolerances were enforced throughout production. Parts manufactured in Detroit fit perfectly into cars assembled in branch factories across America. The Model T used over 5,000 individual parts, all interchangeable, enabling production of 15 million vehicles between 1908 and 1927. It would have been possible without the measurement-based precision that Whitworth had insisted on and American manufacturers had dismissed 50 years earlier. World War I proved how completely American manufacturing had transformed. When the United States entered the war in 1917, industrial mobilization required producing millions of rifles, machine guns, artillery pieces, and aircraft engines in months. The difference from the Civil War was stark. Parts were actually interchangeable. A rifle damaged in France could be repaired with parts manufactured in Springfield, Rock Island, or any contractor facility. The Liberty aircraft engine, producing over 400 horsepower, was manufactured by multiple companies with fully interchangeable components. American production methods built on Whitworth's precision principles were so successful that Britain adopted American techniques. The methods flowed back across the Atlantic, refined and amplified, but fundamentally unchanged from what Whitworth had prescribed in 1854. The standardization revolution continued through the 20th century. The International Organization for Standardization, founded in 1947, built global manufacturing standards on the precision measurement principle Whitworth pioneered. Modern factories routinely measure to millionths of an inch, using instruments Whitworth would recognize in principle, if not in form. Computer numerical control machining uses digital precision, but the fundamental concept remains unchanged. Establish a reference standard, measure against it precisely, enforce tolerances strictly. Statistical process control, the foundation of modern quality management, requires the precision measurement capability Whitworth developed in 1841. Global supply chains exist only because measurements are standardized and enforced. A component manufactured in Taiwan fits into an assembly in Mexico because both factories measure to the same standards with the same precision. Whitworth's legacy is visible everywhere. British standard Whitworth threads still appear in vintage machinery. His true plane surface method remains the technique for calibrating precision equipment. Measurement-based quality control is universal in manufacturing. The principle of geometric reference standards underlies modern metrology. Return to May 1st, 1851, the Crystal Palace in London. Joseph Whitworth measuring American rifles with instruments precise enough to reveal what celebration obscured. American manufacturers winning medals for manufacturing prowess built on inconsistency they couldn't detect. Whitworth saw ambition and ingenuity, but also the lack of precision foundation that made their claims hollow. Americans saw unnecessary British fussiness about measurements too small to matter. What actually happened was that American manufacturing dominance was built entirely on the precision principle Whitworth championed and Americans insisted was excessive. American textbooks still credit Eli Whitney for interchangeable parts that never actually interchanged. They rarely mention Joseph Whitworth, whose measuring machines made interchangeability possible. Every smartphone, every automobile, every appliance depends on manufacturing consistency that Whitworth proved was essential and Americans proved was impossible without his methods. America didn't have manufacturing consistency in 1850, so a British engineer's obsession with measuring to the 10,000th of an inch gave them the tools to enforce it, even though they never admitted they needed his help. The precision revolution that built modern manufacturing was invented in Manchester, proven necessary by American failure, and adopted everywhere while crediting no one.